Lovely student, once again, you're welcome for the continuation of our lessons. Today we are going to continue with what we started for this term. Last week we were looking at plane geometry, specifically angles. And we said that angles are formed when two or more lines appears to meet at a point. Then an angle is being formed. So if we have a line from this direction, another line from this direction, another one from this direction here, the meeting point of these lines produces an angle, and such an angle can give us a various portion of angles which we can easily determine. So we can have something like angle A, angle B, angle C, angle D, angle E. Then of course we'll say that angles are formed when two or more lines meet or appears to meet at a point. Basically, we have two main descriptions of angles which meet at a point. One, considering the description of angles. We have one, what is termed as angles on a straight line. Angles on the straight line. Then B, we have angles about a point. Angles about a point. So we are going to consider these two descriptions of angles that we have. First of all, we'll be looking at angles on the straight line. Angles on the straight line behave in a different style, looking at the various kinds of angles that we have. Angles on the straight line, they fall on the adjacent line. Means that they are angles that do not exceed the adjacent straight line. So if we have a normal adjacent straight line this way, and we have a line coming from this direction here, assuming to be an angle, another one from this direction here, assuming to be an angle, that means that they are on the straight line. So the angle formed will be A, angle B, and angle C. And these angles are on the straight line. So we term these as angles on the straight line. And their basic principle is that they add up to 180 degrees. So mathematically, we can display this as A plus B plus angle C, all equal to 180 degrees. And one important rule about angles on the straight line that we need to take note of: angles on the straight line do not exceed the adjacent line. Means that they all fall on the level of the straight line, where the angles are being produced at the level on that straight line. And that is how we can determine or we can identify the angles on the straight line. Let's look at angles about a point also. With angles about a point, they behave as if they are going round. As usual, we have a certain play object which is known as merry-go-round. Realize that everything will be moving around as if it's a circumference of a circle. And that is how angles about a point behave. With angles about a point, what usually happens is that the various angles exceed the adjacent straight line. So let's say that if we have this, the adjacent straight line, such as this, we have an angle moving from this direction here. This angle crosses through this. We have another angle crossing through this. So they will be meeting at a common point here, but they have exceeded the adjacent straight line. So several angles are being produced here. We can have angle A, we can have angle B, we can have angle C, angle D, angle E, angle F. So we could see that all the various angles are moving around in a circular motion or in the circular form. And this is what we can base on that to describe these as angles about a point. So mathematically, we say that angles about a point, we have angle A plus angle B plus angle C plus D plus E plus angle F, all equal to 360 degrees, because they are behaving as if they are moving around or a circumference of a circle. And that is the description of angles about a point. So basically, angles about a point and angles on the straight line can easily be differentiated. With the angles on the straight line, they do not exceed the adjacent line, as we can see from the board. But with angles about a point, they do exceed the adjacent line. So several angles are produced around the various side of the other angles. That is angles about a point. So angles about a point add up to 360 degrees. All the various angles add up to 360 degrees. Angles on the straight line, the angles add up to 180 degrees. We also have some angles which are formed within right angle. And with right angle, we could realize that it is formed by a perpendicular line meeting an adjacent line. So we have a perpendicular line here meeting an adjacent line. Then right angle is being formed here. Right angle produces an angle of 90 degrees. So this is the symbol for the 90-degree angle. In that case, it means that some angles can also involve itself within the right angle here. Let's look at how we can determine angles within right angle. Assuming we have, that is the right angle, an angle divided this way, where we have angle A here, and we have these given as 30 degrees. And the question says we are to calculate an angle what? A. To calculate an angle A, first of all, we need to ask, is this angles on the straight line, or is this angles about a point, or is this angles within right angle? And we could realize that these are angles formed within right angle. Then the principle of this is that all angles formed within right angle add up to 90 degrees. So basically, whatever we have here will be added to 90 degrees. So we have, therefore, to have our solution, we have A plus 30 degrees, or equals 90 degrees. Then we have angle A equals 90 degrees minus 30 degrees. Angle A equals 60 degrees. So it means that the angle A plus this angle 30 degrees should be equal to the principles of the right angle. And that is what exactly we have on the board. Let's try some questions also on angles on the straight line and angles about a point. Let's see. Example 2. Example 2. We have been told to find the angle X in the diagrams. the first diagram A. We have this angle, this, and we have that of this. So this side has been given as 30 degrees. We have this as angle X, and we have this as angle 70 degrees. Now the question is, we are to calculate for angle X. How do we determine angle X? So what we need to do here is, first of all, to examine this, whether it is angles on the straight line or angles about a point, or angles formed within right angle. These are angles on the straight line because we can identify that, or we can easily see that all the angles are falling on the straight line. So basically, the angles here should add up to 180 degrees. So we'll have, therefore, angle 30 degrees plus angle 70 degrees plus angle X equals 180 degrees. 70/30 will give us 100 degrees plus X equals 180 degrees. So we have X equals 180 minus 100 degrees. X equals 80 degrees. Then the first part of the angle has been determined, which is angle what? X. Is it difficult to calculate angles on the straight line? All that you need to do is that observe the angle given, whether they are on the straight line or they are exceeding the straight line. If they are on the straight line, then the principle is that they should add up to 180 degrees. Now let's take one question also about angles about a point. Now let's assume we have that is B. So we have the adjacent straight line here. We have another line here and another one at this side here. So this is angle 120 degrees. We have 2x. We have 40 degrees. We have x. We have 35 degrees. This is what we have. And the question is, we are to calculate for the value of x. This is angles about a point. Why? Because they are exceeding the adjacent straight line. So we could see that angles are formed at the top here and angles are formed below the adjacent straight line. So mathematically, the angles are moving as if they are circumference of a circle. So all the angles here should add up to 360 degrees. So mathematically, then we'll have 120 degrees plus 40 degrees plus 35 degrees plus 2x plus x all equal to 360 degrees. So this is what we are supposed to do. And that tells us that these angles are on the straight line and they move about a point. Now let's see. 120, 40 will give us 160. 160 plus 35 will give us 195. So basically we have 195 here plus that is 3 what? X equals 360 degrees. So 3x here, grouping like terms, we are grouping. So 3x will be maintained whilst we move 195 to the other side. So we have 360 degrees minus 195 degrees. So we have 3x equals 360, 195. Let's go through some subtraction here. 360, 195. We borrow 1, 10. We have 5. This is 5. We borrow 1, becoming 15. And that will give us what? 6. And this is now left with 2. We have 1. So we have 165 degrees. We are solving for the angle x, and we have the coefficient of x, which is 3. So we divide both sides by the coefficient. We have 3x out of 3 equals 165 degrees out of, that is 3. 3 will go through itself, 1, 1, then 3 into 165. So we should be able to work our long division. Let's go through our long division. We have 165 divided by 3. 3 is 9, 3, 4, 12, 3, 5. It's giving us 15. Remember what? 1. Then this 5 will be drawn closer to this. So we have 3, 5. It's giving us what again? 3, 5. So 3, 5 will give us 15. It means that 3 times 55 will give us 165. So 3 goes here, 1 goes here, is 55. X is equal to 55 degrees. And this is how we have been able to arrive at our value of x. And this is how angles on a straight line, angles about a point, and angles within triangle, angles within right angle behaves. Angles within right angle add up to 90 degrees, earlier example that we solved. Angles on the straight line add up to 180 degrees. Angles about a point add up to 360 degrees. Students will take more examples as we progress in our next meeting. Thank you very much, and we'll see ourselves another day for the continuation of our lesson. Thank you.